Video we will solve questions based on biasing. So in the first question they have said that threshold voltage of the MOSFET is 3 volts and the input voltage is changing from plus 10 volts to minus 10 volts. In this case, what is the maximum and minimum values of Vg required such that proper sampling and holding is possible? In case of maximum voltage, if the input voltage is 10 volts, this node potential will be drain. In NMOS, the higher node voltage will be drain and the lower node voltage will be source. This is source. So on proper sampling, drain should be connected to source. I mean 10 volts has to transfer properly. For that, Vg should be 13 volts in this case. If Vg is equals to 10 volts, Vs will go up to Vg minus Vth, that is it will go up to 7 volts. When Vg is 13 volts, Vs can go up to Vg minus Vth, that is 10 volts, or at this point Vds will be 0. So the maximum node potential at Vg is 13 volts. Similarly, when minus 10 volts is present here, this node potential will be source and this will be at 0 volts, this will be drain. So for from the graph we can see that when Vi is equals to VDD by 2, Vout is also VDD by 2. So since the current in PMOS and NMOS is equal, we can take both MOSFETs in saturation, because at this point both will satisfy the condition of saturation. NMOS will be in saturation and PMOS will also be in saturation. So the current will equate the current equations. For NMOS it will be half mu on C axis 100 micro into WL of N into VGS is VDD by 2 and VT is 0.7 volts, and it will be equal to half mu PC axis 40 micro WL of P into VSG will be again VDD by 2 minus threshold voltage is 0.9 volts. Given VDD as 3 volts and VDD by 2 will be 1.5 volts and VDD by 2 minus 0.9 is 0.8 volts. What I have done is I have brought this to this side, WL of N by WL of P. It will be 0.6 square into 40 micro by 0.8 square into 100 micro. If you solve, you will get 0.225 as the answer. So there the ratio of WL to WLP is 0.225. And this is in this question they have asked us the output current I out. Basically in this biasing based question we are finding out the operating voltages and operating currents, basically ID comma VDS related problems. So the current flowing here is 1 milliamp. In this MOSFET 1 milliamp will flow. WL of this MOSFET is 3. So the current flowing here is 1 milliamp into 3 by 2, that is 1.5 milliamp. So 0.75 milli 0.75 milliamps current will flow in these two transistors in this way, 0.7 milli and 0.75 milli. Here 0.75 milli is flowing. WL of this MOSFET is 40, so this is 10 times this, sorry 4 times this, so 0.75 milli into 4 times current will flow in this, so 3 milliamps of current will flow in this MOSFET. The answer is 3 milliamps. In the next question they have said WL of M2 is twice that of WL of M1. The two NMOS transistors are otherwise identical. Muon, Cox, VTH are identical for both transistors. The threshold voltage for both transistors is 1 volt. VTH is 1 volt. Note that VGS of M2 must be greater than 1 volt. So VGS of M2 should be greater than 1 volt. Of M2 should be greater than 1 volt. Current through NMOS transistor can be modeled as mu1 Cox WL into VGS minus VT into VDH. This is a triode equation. So M2 is in saturation. Why? M2, the gate voltage is at 2 volts and the drain voltage of M2 is at 3.3 volts. So M2 is not for M2 VD is greater than VG minus VT. 3.3 volts is greater than 1 volt. So M2 is in saturation. M2 is in saturation region, but M1 will be in triode region, because they have said that VGS of M2 should be greater than 1 volt. So this has to go below 1 volt. Then this equation will not satisfy for M1. For M1, VD will be less than VG minus VT. This is 1 volt. This is less than 1. VD has to be less than 1 volt. So this equation will satisfy, and this will be in triode region. Now we have to find out the value of Vx. For this we have to write the current equations for both M2 and M1 and equate them and find the value of Vx. We said M2 is in saturation region, so the current for this is half mu 1 Cx W by L. I am taking as K, half K times of Vgs minus Vth whole square. Vgs for M2 will be 2 minus Vx, and Vt is given as 1 volt. And for M1 is in triode region, so it will be K. VGS will be 2 volts for this, and VT is 1 volt. 2 minus 1 into VDS. VDS is Vx, that is into Vx, minus half VDS square Vx square by 2. If you solve the quadratic equation, you will get the answer. I am not solving here. In the next question, an N-channel enhancement mode MOSFET is biased at VGS greater than VTH and VDS greater than VGS minus VTH, where VGS is gate to source voltage, VDS is drain to source voltage, and VDS is threshold voltage. Considering channel length modulation effect to be significant, the MOSFET behaves as I have said in earlier video, when there is channel length modulation, ideally it should behave like this, like a constant current source. But when we have channel length modulation, it will have a finite slope, so it will behave as current source with finite output impedance. This is the question. It will have finite or not output impedance. This is like ideal current source. This is practical current source with some finite output impedance. And then in the next question, MOSFET WL is given. VGS is 0.7 volts, VDS is 0.1 volt, mu1 Cx is 100 micro, VTH is 0.3 volts, WL is 50. Now we have to find out the transconductance of the amplifier GM. Before finding GM, we should know whether MOSFET is operating in which region. If VDS is greater than VGS minus VT, this is saturation. Now VDS is 0.1 volt and VGS is 0.7 volts, VTH is 0.3 volts. Clearly this is less than this. 0.1 volts is less than 0.4 volts. So the MOSFET is in triode region. And in last video I have said that GM in triode region will be mu1 Cx WL into VDS. mu1 Cx here is 100 micro, WL is 50 and VDS is 0.1, that is 500 micro, 0.5 milliampere per volt. This is GM. Before finding out the GM, we should check whether the MOSFET is in saturation or triode. In this case it is in triode, so we have to apply GM equation in triode.